Hello friends, today we are going to start with a new reading which is firm and market structures. Before starting with the reading, let us understand a few basic concepts of economics first which are necessary to understand the readings. Okay, let's have a quick look at this table which summarizes the few information about the cost of a firm whose output is given in this column A. Output is from 0 to 5. And second thing is total fixed cost is given. So total fixed cost is nothing but the fixed cost which are costs that you need to incur irrespective of the level of output produced. The example of total fixed cost can be say rent. You have to pay the rent of the office building of the or the factory in which you are operating irrespective of whether you are producing any output or not. So total fixed cost can be assumed as example is rent. Second cost, this cost is same at all levels of output. Okay. Second type of cost is total variable cost. Total variable cost are the costs which are directly dependent on the level of output. So as the output increases, total variable cost also increases, and as the output decreases, total variable cost also decreases. In this example, I've assumed for 1 unit, total variable cost is 6 per unit. For 2 units, total variable cost is 10 per unit, and so on. Okay. These variable costs can increase linearly or non-linearly depending on the type of industry you are in. So the main point to remember is total variable cost of the cost that increases as the level of output increases. Now, third type of cost is total cost. So total cost is nothing but sum of total fixed cost plus total variable cost. It is given as column B plus column C. So 12 plus 0 is 12 for 0 units. For 1 unit, 12 plus 6, it's 18, and so on. So total cost is the sum of total fixed cost and total variable cost. Now let's have a look at average fixed cost. Average fixed cost is nothing but fixed cost divided by the output produced. So first one is 12 divided by 0. It's at 0 unit of output. Average fixed cost there is NA. We can ignore it. For 1 unit, it is 12 divided by 1. It's 12. For 2 units, it's 12 divided by 2. It's 6. Okay. As you can see in the table here, the average fixed cost is decreasing. So in this chart as well, where quantity is in the x-axis and price is in the y-axis, we can see that average fixed cost, the curve for average fixed cost is downward sloping. It reduces as the level of output increases. Why it happens? Because the fixed cost will remain the same irrespective of the level of output. If you produce more and more, then the cost is distributed in the units of output and it reduces as the output increases. Okay. Now let's move to total average variable cost, which is every total variable cost column C divided by output column A. Okay. Here you can see that average variable cost is it's first 6, then it reduces till 5, and then it again started rising. So average variable cost in this diagram is a U-shaped curve. Average variable cost is a U-shaped curve. It first decreases, reach the bottom, and then increases. Okay. Now let's move forward to average total cost. Average total cost is nothing but total cost divided by output. This is also a U-shaped curve. It first decreases, reaches in this diagram here. Average total cost is also known as AC, average total cost ATC, or average cost only, it's AC. Um, Both are interchangeable. So average cost also first reduces, reaches the bottom in this quantity Q. At this quantity, we say that this is the optimal quantity that can be produced at the minimum feasible price. So you can see the output produced here is produced as the lowest cost possible. Here I've highlighted in red the average total cost where it's 9. It's the lowest cost and it's the minimum cost, and the feasible quantity produces 4. Okay, and again average total cost increases after reaching the low, as seen in this curve, U-shaped curve. After reaching the low, average total cost increases. So in this average total cost, you see I've marked this point as Q. At this point of Q, you see if you are producing at any quantity before Q, you see your average cost is decreasing. That means if you produce one more unit, there is what do you say? There is a capacity to reduce your cost. Okay, so if you are producing anywhere before Q, you are set that you are achieving economies of scale. That means by producing one extra unit, you are reducing your average cost per unit. Okay, at this point Q, this is the optimal operating at the optimal capacity where all the resources are using efficiently and are producing output at the lowest average cost possible, right? And if you are producing at any quantity after Q in this region, that means that you are producing at diseconomies. You are in diseconomies of scale. That means as you produce an additional unit, your average cost increases. Okay, this is the diagram that you should know how to prepare average total cost. And this point Q is the output, the produce at the lowest feasible cost. Okay, now let's have a look at the relationship. Now this is the MC. So MC is called as marginal cost. What it means is additional cost of producing one more unit. Suppose for producing one unit, you are incurring total cost of 18. Okay, but before that, when you are producing nothing, you are incurring the total cost of 12, right? So marginal cost of producing one unit is additional one unit is 6. You are this is TCN minus n plus 1 minus TCN. So total cost of producing one unit minus total cost of producing 0 units. This is 6. Let's say another example, 3 units. For 3 units, total cost of producing 3 units was 27, and when we subtract total cost of producing 2 units, this is 22, you get 5 units, right? So now let us understand MC's additional cost that you are incurring to produce one more unit, right? Now let's have a look at the relationship between MC and AC. MC curve, as you can see, it first falls, reaches the bottom, and then again rises. So MC is also a U-shaped curve. So MC, AC, and AVC. These three are the U-shaped curve. So here in the highlighted columns, you can see that MC and AC are equal $9 at 4 units of output, right? So this output is highlighted here. This is the point at Q where your cost is minimum. You see, the cost is $9 here. I agree that the cost is $9 here also, but there is still scope of producing one more quantity. So you always want to manufacture more and more quantities so that your profit also maximizes, right? So we need to have a point where our output, the quantity produced is the maximum. So we see at the 4 output, your AC is equal to your MC. AC is a U-shaped curve. MC is also U-shaped curve. And the point where MC is cutting AC, this point Q is the point where your cost is minimum. Your AC's curve is the lowest. So this is the point of where your cost is the minimum one. Okay. So whenever your goal is cost minimization, you need to produce units where MC is equal to AC, right? You need to remember this relationship. Whenever your goal is cost minimization, you need to produce till the quantity where MC is equal to AC. This is the point of cost minimization. Now, let's have a look at another short concept. In short run, let's say you have started juice business, right? For juice business, let's say there are two kind of cost. First one is variable cost of purchasing the juice, and the second one is the fixed cost. Let's say you have hired one helper. Okay, so these are, let's simplify things. These are the two costs. One is variable cost of juice, and one is fixed cost of the helper, salary of helper. So what economics says, in short run, if you are able to recover your variable cost, all the variable costs, let's say the cost of juice produced from the retailers, if you are able to recover these costs by selling the juice, then you should continue doing business. In short run, it's okay if you are unable to recover the fixed cost, which in this case, your salary for the helper. If you are unable to recover the fixed cost, then it's still fine. You should continue doing the business. But in long run, if you are unable to recover both your fixed cost of salary of helper and your variable cost, the quantity of juice purchase, then you should, if you are able to recover both this fixed and variable cost, then you're doing good. You should continue doing the business. But if in long run, if you are unable to recover on one cost also, if you are unable to recover either variable cost or fixed cost, then you should stop doing your business. At that point where you should stop, it's called shutdown point. So shutdown point is the point in short run, if you are unable to recover variable costs, this is the point of shutdown. You should stop doing your business as it is not going to be profitable in short run if you are unable to recover variable cost, and in long run if you are unable to recover either of the variable cost or the fixed cost, right? So this is the short concept that you should know. Now moving on to the concept for revenue, we have learned the concept for cost. Now let's have the look at this table. At this table also, let's say this is the output level produced at this price. You see, as the output increases, the price level decreases. Okay, why it happens? Because if you need to sell additional unit, you need to reduce the prices. So for from 1 to 7 output, the prices are, I've assumed the following prices. Let's say this is the total cost for these for producing these outputs. I've not given bifurcation because in this table we are talking of more for revenues. Okay, now we have to calculate TR. TR is total revenue. Total revenue is nothing but output times price. So when you multiply A and B, you will get total revenue. It is given in this column here, right? And when then there is AR. AR is average revenue. So AR curve is given by total revenue divided by output. So when you divide total revenue by output, you get AR, average revenue per unit. If you look closely, then this AR curve and this price curve is exactly the same, because AR curve shows the average revenue that the supplier is willing to sell at this particular price, right? No, I'm sorry. AR curve is the average revenue that is demanded by the buyers at this particular price. So if we say, let's say at this table here, for 5 units, for let me just remove all this. For 5 units, if you notice here, you can sell 5 units at the average price of 4. So you can say that AR curve is equal to the demand curve. The quantity demanded at 4 rupees is 5 units, right? So you can say that AR curve is also the price curve, is also the demand curve for any firm. Okay, you should remember this. AR curve is also the demand curve. Now let's have a look at the profits. To calculate the profit, we just simply subtract total cost from total revenue, D minus C. So you subtract it and you will get the profits. 233, then this point is the break-even point where total revenue is equal to total cost, and then you started incur losses from unit 5 units onwards. Okay, now MR very similar to MC. MR is a additional price that seller get on selling additional units. So for 1 unit, MR is getting 8 rupees. If he sells 2 units, then what is the additional revenue he is getting? 14 minus 8, it's 6. Okay, it's very similar to MC only. So MR is marginal revenue, which is additional price that seller is getting on selling one additional unit. Okay, so we plot this MR curve also, and we plot the AR curve here. As you notice in this diagram, that AR is downward sloping. It is reducing. It's not increasing like AC, right? From 8, 7, 6, 5, 4, 3, 2. It is the downward sloping only. It does not rise again. So this is the downward sloping curve. This is our AC. And you see, if we plot MR on the same diagram as AC, you see after 8, MR started reducing, and at any quantity, let's say at this quantity, MR is less than AR. So it is shown below as blue line. And you can see here at this quantity, when MR is equal to 0, you can see in our diagram, when MR is equal to 0 at this quantity, our total revenue is maximum at 20, right? After that, total revenue also decreases. So when MR is equal to 0, our total revenue is maximum, right? You need to remember this relationship. From this table, it is proved that when MR is equal to 0, our TR is at maximum. Okay, now let's have a look at the relationship between MR and MC. So you see in the highlighted cells here, when MR is equal to MC, then our profit is maximum as 3 per unit. Again, I agree that profit is 3 here also, but we also need to ensure that we are producing at the maximum quantity possible. So at quantity 3, our when MR is equal to MC, our profit is maximum as 3 rupees per unit. So when we plot MC, MC is also again a U-shaped curve. Here at this point, we say that it's the 3 unit quantity is equal to 3 and our profit is maximum here. Here you can see that MC MR curve cuts it can happen MR curves cuts MC at another level, but if let's say if MR curve cuts MC at Q1, then what happens is there is additional, you see MC curve is going like this. There is additional when MC curve is started reducing, when it's going down, it means that marginal cost is reducing on producing extra units. So we need to produce till our marginal cost is at the lowest. So when MR cuts MC, the profits is maximum. And there is one another condition. For profit maximization, there are two conditions that you need to remember. MR should be equal to MC, and your MC should rise after touching MR. You see here, MR when equal to MC, it should rise up. MC should rise after that. If you notice here, you see MC is rising after cutting MR at the lowest. So for profit maximization, if you say where our profits is maximized, there are two conditions. I'm writing it here. First one is MR should be equal to MC, and second condition is MC should rise, should be rising after cutting MR. Okay, so these are the two conditions that are necessary for achieving the level where the profit is maximized. Okay, you need to remember that. Now, let's have a look at this graph here. This graph here. Let's have a look. This is the kind of illustration which shows the concept of economic profit and normal profit. Let's see. So how do we calculate profit? Either using total cost or total revenue approach, or using average cost and average revenue approach. Here we are using the cost using average cost and average revenue approach. Okay. So you can see this is the AR shown as the red, and at this point where AC 0, this is first scenario when our AC curve cuts AR curve at this point at the lowest. Okay. Now if you say how do we calculate profits, this is average revenue minus average cost. At this point here, our average profit is 0. AR minus AC, you can see at this point it's 0. This is the case when we say that the firms are incurring normal profits. So the point of normal profit is this one, where AR curve is exactly equal to AC curve at quantity Q. For this curve, if I'm specifically talking of AC 0 curve, for a moment, please ignore AC2 and AC1 curve. I'm just talking of AC 0 curve. In this case, when when AC is equal to AR, this is the case of normal profits. No profits, no loss means normal profits for the producers. Now, let us suppose at this quantity only, if we are manufacturing at AC1 curve, our average cost curve looks like this. It cuts AR at 2 points, then what is the case here? You see, if you are operating at this price P, so your average cost is this one, this much P0, and your average selling price is this P1. So this portion here, this is your profit, right? Your cost curve is below a revenue curve. That means you're in the profit, right? So this green highlighted portion is the profit that you're earning. This portion in this graph is known as economic profit. If any firm is able to operate below AR, whose cost curve is below AR, that means the firms are earning economic profits, right? In the similar case, now let us assume that we are operating not at AC1 but at AC2. Okay. Now let us assume that we are operating at this cost curve AC2. Now at the same quantity Q, if we see our revenue is at this point, let's say this is P0, and our cost is at this point. This is P1. So this green area, now highlighted green area, is the economic loss at which you are operating, at the producer is operating, because your cost curve is way above your revenue curves. That means you are incurring more and selling at less. You are getting economic profit, economic losses in this case. So whenever this is a condition of economic losses, it is always advised that you should leave the business and start something else. All right. So these were the few concepts that I felt that you must know before starting the reading. Okay. Next, we will start with the original reading. We will start with perfect competition.